Okay, good morning everybody. We are going to do multiplying decimals by decimals, which is 4.3. It is very, very similar to the one we did in 4.1, but there is a difference that will make a huge difference in your answer, because what we are doing is we're actually multiplying a piece by a piece. So we're not any longer multiplying them several times over. We're doing a piece of something times a piece of something. So what I'm going to do first is I'm going to show you an actual example, and these are a 10 by 10 grid. And so I am going to write down the first question, and we are going to demonstrate with a model what 0.2 times 0.6 is. 0.2 times 0.6. I'm going to show you with a model why it works that way. And what I'm going to do first is I am going to take this highlighter. You can just simply shade with your pencil or something like that. But what I am going to do is I'm going to shade in 0.2 of this. So we're going to pretend that this is Mrs. McKinley's very favorite chocolate bar. And I'm in a big family, and they had to break off a piece for me, and this is my piece. And so I am going to say, okay, I am only going to eat 6/10 of it right now. So what I'm going to do is I am going to now go this way on my grid, and I'm going to go 1, 2, 3, 4, 5, 6. And I'm going to shade in 6/10 of my 2/10. And it's okay if you want to shade this part too. It doesn't matter. That's the part that never existed in the first place. And all I am going to count is this right here is the whole piece that was given to me by my mom. But I am only going to eat, the 2/10 was given to me. I'm only going to eat 6/10 of my 2/10. So if I look here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 little squares that I'm going to eat. How would I say that in a decimal? Can somebody raise their hand and tell me how I would say that in a decimal? Meredith? How many are in the whole thing? Yep, so I only have 12 out of the 100. So how do I write that down, Alice? I have eaten 12 hundredths of the chocolate candy bar my mother gave me. 12 hundredths. Now notice there is absolutely no way to get beyond that 1. If you have a decimal times a decimal and you're over 1, you have a problem because you're multiplying it. You're taking a piece of a piece. So remember, I got this whole piece, but I'm only going to eat a piece of the piece that was given to me. And I still have, how many hundredths do I have left to eat if I were to count these down here? Parker. So right here I have 0.08, so I have 8 hundredths left that I can eat like right before bed just because I like to eat chocolate at night, right? So that is the model for doing the graph. We're going to try another one together, and I'm going to put it off to the side. We're going to try 0.3 times 0.8. So the first thing we're going to shade down is we're going to shade 3/10 down. So go ahead and do that, and I am going to take my grid offline and I'm going to shade it. If you're watching the video, you can do this and pause me. And hopefully what you have come up with is you have shaded 3/10 of the square. And now we're going to go the other direction. And we are going to shade. So I was given 3/10 of something. But I am only going to use 8/10 of whatever I was given. So maybe I was given some fabric from the fabric store. I got 3/10 of a yard, and of that, to start my project, I only need 8/10 of it. So I know that all but 2 are going to need to be shaded, and I chose yellow and blue because they make green, and that's kind of fun. So anything that I shade here is going to be green. This is my answer, the one that changed colors into the green. Who can tell me how many little squares out of 100 are shaded in? Go ahead, Eric. I don't count 44. Oh, sorry, 24. Yes, sorry, that's my bad, my ears. And it's 24 hundredths. So this is the whole yard of fabric or candy bar, whatever. And I only have 0.24, 24 hundredths of it is my answer. Okay, so that is the model. There are more models like this in the book, and you will be asked to do a couple of these in your assignment. You all may have a sheet of this paper or use this same one turned over on the back to do those. I use the bigger squares for the model because it works better on the video. All right, so we are going to talk about the key concept. After that, we are going to talk about how do we place that decimal when we don't have time to draw a bunch of little squares. And for goodness sakes, we're going to have up in the thousands. We don't want to draw like 1,000 little squares. So Mrs. McKinley, how do we do it? So for decimals, you always multiply decimals like they are a whole number. Multiplication problem. And I'm going to show you this right afterwards, so don't worry if you're like, I don't understand what that means. Then place the decimal point. And you need to count the total number of places in both factors and swoosh it. And I'm going to try to draw a Nike swoosh. That many places to the left. Now these are a lot of words, but when I show you what you're doing, it's really quite simple. So the first one that we did with the model was 0.2 times 0.6. Shout it out. What is 6 times 2?
12.
Okay, so 6 times 2 is 12, and I'm going to count how many total places are in both factors. So here I see 1, 2 places. So this is one place after the decimal. This is the second place after the decimal. Watch what I do. I'm going to swoosh 1, 2, and I'm going to place my decimal right there. Same thing with 0.3 times 0.8. I have 1, 2 places total after the decimal. 3 times 8 is? Can I shout it out?
24.
And then I am going to swoosh my decimal 2 places here. So now let's try 0.12, 12 hundredths times 0.3. Okay, somebody just tell me what 12 times 3 is. Just, yeah, Nathan.
36.
It's 36. Okay, now we've got a problem here because how many total places, total numbers are after the decimal? You have to remember, you have to count all the numbers that you see. How many numbers do you see after the decimal, Jane?
3, but you can add a 0 in front of it.
And this is not a cows come home 0. This is actually a placeholder 0. So she counted 1, 2, 3 total places. But watch what happens. We swoosh 1, 2, uh-oh. But you can swoosh one more over, place your decimal, and then add that 0 to kind of sit in that little divot that we created right there. So this, if we have 12 tenths or 12 hundredths times 3 tenths is what I meant to say, you're going to end up with 36 thousandths. Notice that when we do a decimal times a decimal, the numbers keep getting smaller and smaller. And I've had kids throughout the years have a big, huge problem with that. But I'm multiplying. Why isn't the number getting bigger? It's because you're taking a piece of a piece. It's like being in a family. You're all used to that. You break off a piece, and then here comes your friend or buddy from down the street, and you're breaking off a piece of the piece that was given to you. So no matter what, you're going to end up with a smaller and smaller number. Let's try 5.08. So our example 1, oh, that's a bad marker. 5.08, 5 and 8 hundredths times 2.1. So I am going to have whoever's watching the video pause it and try that one on your own. If you are working it, I want you to work quickly at your desk, and I am going to solve this right up here. So peek up here, and I want thumbs up if you have the answer. No, that's a great point. In multiplication, the decimals don't line up. You just need to know, and we can tell you where the decimal is going to go already. How many total places, hold up your fingers, how many total places do you see after the decimal? How many swooshes are you going to make? 3. 1, 2, 3. So I had one student one year do this, 3 swooshes, so that they know when they get their final answer, they've got to swoosh 3 places to the left. So let's solve the arithmetic, which is just the multiplication, and make sure this is correct. This is why I'm being a stickler on Know Your Facts. Okay, hopefully you have gotten the answer that I have up here. Now, I need you to tell me what 2 numbers the decimal needs to fall between. And remember, we have a little hint up here, because we can figure out at the very beginning of the problem where it goes. Eli, where do you think it goes?
I think it goes between the 0 and the 6.
I think you're exactly right. Because if you started over here and you said, okay, I need to do 3 swooshes, you'd go 1, 2, 3, and you'd put that little guy right there. Now, I want you to realize this decimal point is a huge deal. There is a big deal between me giving you 10.668 of something and 10,668 of something. It's a huge difference. So if you have trouble figuring out where that decimal goes, really review this lesson and make sure you count those swooshes correctly. Let's try for a moment 12.7 times 2.9, and I'll write that up here.